Let me start my presentation. At first, about ACS series. We think you already know the detailed information about ACS, but we would like to review the ACS series because this model is very appropriate model for DIC application. And the ACS series focus on the high-end shooting range. The range at over 10,000 frames per sec, ACS has most advantage in high resolution in high-speed camera suppliers. And ACS-1 can shoot at full resolution of 1 megapixel at 54,000 frames per sec. At the range of 100,000 frames per sec, ACS can shoot twice higher resolution than other suppliers' model. And the ACS has high sensitivity of ISO 100,000. And ACS-3 is compact model of ACS-1. It is smaller and lighter than ACS-1. And ACS-3 can shoot at full resolution of 1 megapixel at 40,000 frames per sec. And we add the image quality mode to ACS-3 recently. In this mode, we can improve the image quality of ACS-3. We will introduce the detailed information about this model another time. And ACS is used for many applications of image analysis, like temperature analysis, and motion analysis, and DIC, so on. And especially, it has a higher resolution at high-speed shooting. So it is appropriate model for DIC application. From now, we will share with you the sample movie of ACS. And this movie is about high-speed tensile test. High-speed tensile test is one of the most common applications for DIC. This test is required to shoot at more than 100,000 frames per sec. So ACS is appropriate model for such test. And this movie is about Hopkins-over test. There are a lot of market needs for such shooting in Chinese market. In Hopkins-over test, ACS is also appropriate model because such test is required to shoot at more than 100,000 frames per sec. And let's move on to the next topics. Introduce about DIC application. DIC means the digital image correlation. And DIC is a method to analyze the deformation of object from image without contact. When you do DIC analysis, it's necessary to spray the entire surface of object before making test. We can get the information about 3D position from random pattern when we shoot with two cameras. And we can see how much the spray particle on the entire surface moves, and we can analyze the deformation of entire surface. The system principle of DIC is based on triangulation and photogrammetry. The distance and angle of two cameras can be defined by using calibration chart. It's enabled to analyze 3D deformation of entire surface from image taken by two cameras. And this is a video of DIC analysis result in tire rotation. We can analyze the deformation with DIC application like this video. About deformation analysis, many researchers usually use the strain gauges. The strain gauges can analyze only single point in the surface, but DIC can analyze the deformation of entire surface in shooting area. This is one of the most advantage point in DIC analysis. A main application for DIC is as follows: and material tensile test, impact test, and drop test, and expansion test. In such tests, many researchers analyze the deformation with the strain gauges, so they might be interested in DIC application. Let's move on to the next topics. We would like to share with you the process from camera setup to analyze the deformation with DIC software. When we set up DIC application with our high-speed camera, we have mainly 4 steps. First one, set up to camera and light source and adjust the shooting area to the object. Second one, taking the calibration using snapshot with MEMRECAM software. Third one, to make test. Fourth one, converts the image data to TIFF data. DIC software can analyze only TIFF data, so we need this work. Fifth one, analyze with DIC software. When we make demonstration with DIC partner, we need to be responsive from setting to camera to transfer TIFF data. We will share with you this process for DIC application from now. From now, we set to camera. And today, we set to ACS to light source to the shooting area. And we use sync cable to synchronize to ACS. When we synchronize to camera, we have to confirm which camera is master or slave with MEMRECAM software. The master cameras means the camera output sync signal. The slave camera means the camera receive sync signal. Usually, we set left camera as master and right camera as slave. And I send you the operation procedure for DIC with MEMRECAM. Please refer to this material when you synchronize to camera. And next, we set the target object. This is already sprayed to create the random pattern. And about spray, and it is usually use the ordinary spray. And this part is usually performed by DIC partner. And it is important to create the random pattern of white and black like this. From now, we will adjust the focus. To focus on the entire surface is very important to DIC analysis. During the test, the target object might be moved. So it's important to increase the depth of field to keep the target in focus. So usually we set a big number of aperture. We will adjust the focus from now. Today we set an 8 number of aperture. And we have to check the entire surface in is in focus in the MEMRECAM software like this. Such setting will affect the good accuracy with DIC analysis. So please remember this point when you perform with DIC application. And next, we will set the two light source. And it's important to set the two light source to the shooting area uniformly. The brightness on the image will affect the good accuracy, and we have to check the brightness on the image is uniformity, and there is no shadow in the target object. We will adjust the two light source from now. Like this, we have to check the brightness on the image is uniformly, and there is no shadow in the target object. And without the saturation in the image. And next, we will take the calibration. When we take calibration, we have to take the calibration more than 15 snapshots of calibration chart at different angle and different position. And about calibration chart, like this, and DIC partner usually has many kind of calibration chart. So they usually select the appropriate calibration chart according to the shooting area. And about taking the calibration, we usually use the snapshot with MEMRECAM. In setting snapshot with MEMRECAM, you can select the bitmap and TIFF data and JPEG data. But you have to select the TIFF data because DIC software can read only TIFF data. So please remember this point when you make demonstration with DIC partner. And when we take calibration, we have to take 4 times is a shooting plane like this. And we have to take calibration 4 times is a shooting plane at different angle and different position. And 4 times is a front side. And 4 times is the back side at different angle and different position. And when we take calibration, we have to communicate with DIC partner. We will try shooting now. じゃあお願いします。お願いします。お願いします。お願いします。お願いします。お願いします。お願いします。お願いします。お願いします。お願いします。お願いします。お願いします。Like this, we have to communicate with each other with DIC partner to give the cue signal. After taking calibration, we have to check the TIFF data for calibration data is saved to the folder you made, like this. After that, check it, and we will actually try shooting from now. And when you synchronize the camera, we have to use a trigger switch to avoid being delayed. And this is a very important point too. So please remember this point when you synchronize the camera. And we will actually try shooting from now. お願いします。After shooting, we have to select the saving area. And we have to save the shooting data to MCF data at first. Today, we use LAN cable, but an ACS can connect the USB 3 cable like this. When you use USB cable, and the download speed is 4 times faster than LAN cable. After saving the MCF data, we have to convert the MCF data to TIFF data. And you have to select the TIFF data and monochrome 8-bit. Because DIC software can read only TIFF data. So please remember this point too. Now we finished the convert the TIFF data. After the convert the TIFF data, and we have to give the TIFF data for shooting data and calibration data to DIC partner. And when we give the TIFF data to DIC partner, it's important to confirm which TIFF data is shooting data and which TIFF data is for calibration data and which TIFF data is for right camera or left camera. The way to create the folder for the calibration data and shooting data, we summarize it into the operation procedure for DIC with MLink. Please refer to this material when you synchronize the camera and when you made demonstration with DIC software. And this is the process from camera setup to give the TIFF data to DIC partner. From now, we will share with you the process to analyze with DIC software. And we need to select the site of calibration chart. And we start analyzing it now. Now we finish getting the calibration data into the DIC software. Next, we need to read the image data. At this part, it's very important for us to specify TIFF data for right camera or left camera too. So, and we need to confirm this information when we shoot with two cameras. And after reading the image data, we can select the area we want to analyze. After selecting the area, we start analyzing. And this time we finish analyzing the data. And we can see the sequence data of deformation and displacement in timeline like this. This is all sequence from camera setup to analyze with DIC software.